So, my hello, my name is Zoy Pradhan, and I am a student at Software College affiliated with Coventry University, and my student ID is 240602. And and today I am presenting my data science and analytics project, focusing on a real estate and property investment potential across Norfolk and Suffolk. The objective of this project is to analyze multiple socioeconomic indicators, especially house prices, broadband connectivity, local crime rates, and educational attainments to develop an integrated decision model that ranks towns from property investment. So now, this is this is the files that I have created to do so. The first one is, as you can see here on my screen, I have a structured the analysis sequentially across this distinct arc script number file no, from file 1, that is injection, then file 2, data cleaning, and then I have file 3 that includes EDF visualization and linear models, uh, and then in 5 we have tables. So in file one, I handle the data identification. I handle the data identification and ingestion phase. I use data table thread for fast loading and tidyverse mapping functions to loop through subfolders for housing, police crime records, and broadband school performance. So this loads core libraries. This is the working environment. Then this is the ingest special postcode lookup for postcode lookup. The three. So these are the comments I have given in the file to make sure the code is understandable. And three ingest HM and line registry housing transaction from 2001 to 2005. Then ingest Norfolk and Suffolk monthly crime record from 2020 to 23 to 2026, and then ingest of broadband matrix, and then school performance, and then school performance, and then the summary to see this is. So to see whether this is working or not, we will run the code. So a key feature here is that I programmatically extracted the academic year directly from folder paths using string matching for a school dataset for so temporal tracking is preserved. So this is one thing, and then to see whether this is running or not. So this is working now. It takes a bit time. This is finished now. So we can see that code lookup, we have this much housing, this crime, broadband, and then school flows and school chaos flows. This is file one. And then moving on to file two. The raw ingested datasets are standardized and filtered and restructured into a 3NF relation SQLite database. A custom helper function clean postcode and normalizes all postcode values into a uniform uppercase format to ensure accurate spatial joins across the table. The script filter spatial lookup data specifically for a target district in Norfolk and Suffolk, defines a primary town reference table and cleans individual entities, including housing, broadband crime, broadband, crime, and school performance by converting data types, removing missing or invalid values, and inner joining them against target districts. Crime data is mapped via LSOA codes, while school record preserve temporal integrity by joining URN identifiers with academic years. So this is the code. So this is data cleaning, initialize data cleaning database construction, then filtering Norfolk and Suffolk target districts, and then defining the main towns, and then cleaning housing transactions is here, and then cleaning broadband speed data, cleaning UK police crime data, and then UK crime, and then cleaning school and school info, and then this is the to create database. So whether this is working or not, we'll see that. So let's clean this first. Then now this has worked. File 2. So now moving on to the task 3. So we have the every plots are generated here, and then this is for EDA and linear regression modeling, and this gives us the visualization of the code. So this is the exploratory data analysis and statistical modeling, and then we have uh, this all, and then first is house prices visualization. So we have what we have here is house price distribution by district of in Norfolk, and then same like this we have for the Suffolk district by district, and then it images, the plots that that gets generated will automatically be saved in plot in a folder called plot. So this is the folder where the images get saved, and these are the these are the these are the bar charts, bar charts by price country trends that will be saved there. And then we have in second we have broadband speed visualization, broadband visualization. This is for average download speed by district, and then for in Norfolk, and then we have a average download speed by district in Suffolk. The box plot will be saved in there, and then we have crime generating crime visualization. This is for to check whether the crime is the code is working or not. In your vehicle crime incident distributed by LSO way in 2024 will be saved there, and uh, then we have monthly drug offense trends that will be saved there. Drug offense, the plot will be saved there in plots. School visualization, attainment its score distribution by district, Norfolk district, and then we have attainment its score distribution by district in Suffolk 2024 to 2025. And then we have plot optimization trend. Yeah, average 8 score trend by district, Norfolk from 2021 to 2025. And then same goes for the software 2021 to 2025, and then statistical analysis and and regression model. This will be generated there. Scatter plots will be generated there. For drop grade F versus average speed, attainment score versus drop offense, attainment score versus house price, and then drop grade versus house price versus drop offense rate, price versus broadband speed. So overall recommendation, this is for overall recommendation and score ranking. Uh, Score ranking. Yeah, so this is what will happen. So to check whether the code is working or not, we'll do work is complete. All plots and models will be saved in plot. So this is where the pixels will be saved for house prices distribution by district in Norfolk, house price distribution by Norfolk, and then we have then then for this all these all will be saved there. So if I were to explain these charts, then it will take a long time. So we'll skip them. So let's put them for now in a new file. We have another table that will be saved here. So uh, our presentation. And now moving on to the file 5 or 4. We have done 3 and 4 question in here in the same file. So in task 5, the pipeline computes normalized scoring matrix across four key pillars, renders a publication grade table graphics, and generates a comparative decision visualization. The script queries the SQLite database standardized headers and map postcodes and LSOA codes directly to eight primary town in Norfolk and Suffolk. It calculates mean and max normalized scores scaled from 0 to 10, 0 to 10 for each domain, utilizing inverted scaling for prices and crime, where lower values represent greater affordability and safety, and direct scaling for broadband speed and school attainment scores. A custom helper function render and save tables, leverages grid extra and grid to format and export high resolution PNG images for tables, which will be saved in plots again. So helper function to draw save, this is what there are comments in codes to know what's going on. So this is what, so to see whether this is working or not, internet speed is high, then where crime rate score, the lower crime is also higher score, then school performance score, and then overall school calculation and ranking. So we have these all. So to see whether this is working or not, we'll do this. So as you can see here too, it's working. So the question is, will it be saved there or not? So we can see it is finished. So here we have mm, the overall score calculation for breakdown overall school ranking, which is based, and then overall property investment recommendation in Norfolk and Suffolk. You can see gateway mark is most, and then town decision matrix key investment pillars, and then top towns by crime scenes. So 10 on 10, and then in you can see here Norwich. So this is all. So, if I were to explain these plots that are created in file 3 as we have seen in file 3, so in this figure, the hospital distribution by district across Norfolk district in 2025, the log scale blocks plot with vast majority of Norfolk properties priced between 100K 100K and almost between 400K with lower price outliers in Great Yarmouth and highest price outliers from 1 to 10 million, 1 to 10 million, 1 to 10 million, 1 to 10 million across almost all districts. So moving on to the second image. So this is also the house price distribution by district in Suffolk. This is also a log scale box plot with the vast majority of with vast with the this is also this is also a box plot with this we can see that the median price at almost 300K. There are luxury outliers of 10 million in East Suffolk, East Suffolk, Mid Suffolk, and Ipswich. We can see here. So Ipswich of 10K of 10 million to that's it. And then moving on to the house price distribution across Suffolk district. So these are the graphs that should be explained. So this contains the average house price district by Norfolk. So we can see here which is higher. So this is South Norfolk is higher than and then Broadland, and then this is average house price by district in Suffolk. We can see that the Burberry has the highest mean price, and then the lowest one is Ipswich, and then this is the mean house trend. The average house price trend in Norfolk and Suffolk between 2021. The Suffolk had prices that were generally higher than the Norfolk between 2021 and 2025. The two countries has reached their peak in 2022. As we can see here, they were in their peak. So that can be explained from here. And then we have the average download speed in box plot. The Northwich has the fastest median download speed, as we can see here, and the lowest would be Kings, and so we can see here this is the lowest. And then we have average download speed in Suffolk, the highest being the most easy report median below to 50 Mbps with Ipswich the highest near 60 MB. Ipswich near the highest with 60 MB bits per second. So we can see here, and then this is the average maximum download speed by district. So we can see here average speed and then max speed. When peak and average speed are combined, Ipswich and then Northwich have the highest score over 150 megabytes per second. So this can be concluded. And then we have the vehicle crime rate. So this box plot indicates that both Ipswich and Norwich have the highest median number of incidents per LSOA in 2024. And then moving on to vehicle crime per 10,000 population in June 2024, we can see that East Suffolk stand out with a vehicle crime rate exceeding 50 incident per 10,000 residents. So we can conclude that East Suffolk has the most vehicle crime rate. And then this is the monthly drug offense trend. Norfolk has also consistently had, we can see that Norfolk has consistently had more drug offense than Suffolk, more offense than Suffolk. It is clear through this graph. And then this is the attainment score. Attainment score. Attainment scores are near 48 in South Norfolk, South Norfolk, and then and a Broadland you can see here, which have the highest median score. Then moving on to the attainment score, its score by the in Suffolk. Suffolk has the median score of 45, which is which with highest score being recorded in Babark. So we can see here. And then this is the attainment score. Its score trained by District Norfolk. So this is in academic year. And then this is the attainment score in trained in by district in 2021 from 2021 to 2024. This is the property recommendations in uh, so this is what Great Yarmouth is most has the most, then North Norfolk has the most. This is scattered house prices versus broadband. Then this is house price versus dog offense rate, alternative score versus house prices, and then alternative score versus dog offense rate, and then broadband speed versus dog offense rate, then broadband speed versus attainment score. So this is all.